Okay, everybody, today is going to start setting us off when we talk about functions. Now, the formal definition of a function we'll get into in a little bit, but I just wanted to let you know a few things about it. They can be used to predict things. So basically, they are rules that give us predicting abilities that I will show you momentarily an example of that. And they can be defined by an equation, table, graph, picture, verbal description. You name it, that's what we can do. So when we talk about functions, you can think back to input-output machines. And you might have learned about input-outputs previously in your math classes, for example, in 6th or 7th grade. So inputs, remember, are always your x values. That's what you put into your machine. Your outputs are your y values. That's what comes out. So if I was using this equation right here, y equals x plus 6. My inputs are my x values right here. So if I would plug 0 into my function machine, 0 plus 6 gives me 6. No matter what, when I plug 0 into my function machine, using this equation, I will only get 6. If I plug 1 into my function machine, if I plug 1 into my function machine, I would have 1 plus 6 gives me 7. So 7 is my output. Let's try another one. If I would plug 10 into my function machine, 10 is my input, I plug it in, 10 plus 6 gives me 16. That is my output. And lastly, if we try one more, if I would plug 20 into my function machine, I go down to get my output. 20 plus 6 gives me 26. So no matter what, whatever you plug into your function machine, your input, which are your x values, you will only get one output, which is your y value. So here are two different tables. We're going to call this table A and table B. These tables they're talking about falling stones. So do you see any differences in these tables? So for example, 0.5, number of seconds, the distance traveled in feet for that stone would be 4 feet. If the stone was traveling for 3.5 seconds, it would be at a distance of 196 feet. However, on the table over here, when the stone traveled for 0.5 seconds, we were at 4 feet. The stone traveled for 2 seconds, we were at 64 feet. If you look a little more closely at this table over here, though, when the stone traveled for 1 second, we were at 4 feet. And then again, it's telling me if the stone traveled for 1 second, we were at 36 feet. How can that be true? How can at 1 second we could have two different distances? How can it make two different predictions at the same time? So anytime it's making two different predictions at the same moment of time, that is considered not a function. And we'll look at a more formal rule, like I said, in a little bit, but I just wanted to get you thinking about that. Same thing here. How can we have at 3 seconds, this stone is at 99 feet and at 196 feet? That can't work. Over here, though, this table, which we're going to look at more closely in a moment, is a function. Because no matter what, the given second, they only had one distance that they were going to. We never had a duplicate input or never had a duplicate of our x values. So looking at this table just a little bit more closely, no matter what, every single input, which are our x values, are different. We never had a duplication of our input. That is one of the factors to determine if a table is a function or not, or if your ordered pairs are a function or not. You can never have a duplicate input or x values. So here we go for an example. They want us to use this equation, d equals 16t squared, to calculate the distance the stone dropped from the given time t. So use your calculator. You're going to plug in 16 times one of your inputs, which in this case is your time or your x's. So I'm going to plug in 0.5 squared. In your calculator, get your answer, and you would have 4. I want you to continue this with the table. Once you have your table complete, you can press play again. But remember, we are using this equation, plugging in our t or our inputs. So here are my table of values. Like I said, all I did was plug everything, all of my inputs or my times, into that equation. So if you didn't get the table of values, make sure to ask your teacher in class. It says, are the distances you calculated equal to the table from lesson 1? Well, basically, I want to know if they're equal to either table A or table B. And in this case, they are equal to the first table in your book, table A. And remember, this was the table that had only one time, only one input for each distance traveled. So now it says, does the function d equals 16t squared accurately represent the distance the stone fell after given time? In other words, does the function described by this rule assign to t the correct distance? Yes, because they had correct input values to each output value. So here's a formal definition of a function you are going to want to write down on your notes somewhere, probably on the blank sheet of paper that's in your book at the very beginning. So a function, it's a rule that assigns each input, which are your x values, exactly one output, which are your y values. They can be described by tables, graphs, equations, verbal descriptions. And this is what you really want to remember to help you. The same x value is never assigned to a different y value. Basically, you can never have a duplicate input or x value. Anytime you would have a duplicate input or x value, if it's occurring more than once, it will not be a function. We're going to look at examples right now. So here's an example. I have two different table of values, well, ordered pairs in this case. Here's one set of data. And if I look particularly at my x values, I have a 0, a 1, a 2, and a 3. Do my x values ever duplicate? Do my x values ever repeat? No. And since they are not repeating, these ordered pairs would be a function. Now if we look over here at my x values, I have a 0, a 1, a 3, and a 1. Ding, ding, ding. The 1 is repeating more than one time. Since it's repeating more than once, these set of values are not a function. Okay, turn your page in your book. This is another example. Can the table below represent a function? Well, I'm automatically going to look at my x values or my inputs. If there is a duplicate or a number occurring more than once, it is not a function. So this table is not a function because of my 5s, because the 5s are repeating. Number 3, give it a shot. And I hope you said that this is not a function, because if I look at my x values, there's an x value that is repeating more than once, and it would be the 7 in this case. Remember, because this input of 7 has two outputs. It has an output of 15 and an output of 10. That can never happen. The reason why it can't happen is because it's not a good predictor of what's happening at 7. At 7, would it be going to 15 or at 10? I don't know. That's why it's not a function, because of this 7 repeating more than once. Last time, if we look at this table, look at your x values. I do not see anything repeating at all. I just have a 10, a 20, 50, 75, 90 in my inputs. So since there's no repetition or nothing duplicating, yes, this is a function. We'll talk more about functions another day with ordered pairs and graphs, but today we just wanted to look at tables. And one thing I did want to point out, a lot of kids say they don't think this is a function because they look at their y values. You can have duplicate y values. Duplicate y values are okay. Mainly when you want to look to see if something is a function, only look at your inputs or your x values. So here's number 5. It takes Josephine 34 minutes to complete her homework assignment of 10 problems. If we assume that she works at a constant rate, we can describe the situation using a function. Predict how many problems Josephine can complete in 25 minutes. So remember, what we always taught you was to put time in your denominator. So we're thinking she can do 10 problems in 34 minutes. All they want us to do is to predict or estimate. So if they're only giving us 25 minutes, predict what you think it might be and write it down in your book. I'm going to say that 25 minutes is less than 34 minutes. So I might do a prediction at, I don't know, 6 problems. Now part B, which is on your next page, asks us to write the linear equation. And we can write a linear equation because it says we have a constant rate. So in order to find our constant rate given 2 values, remember, we always put something over time. In this case, we would be doing your problems over time. So I would have 10 problems in 34 minutes. This right here, my friends, is your constant rate. And if it doesn't divide nicely, just leave it in fraction form. So 10 over 34 is my rate. If I wanted to write that as my equation, remember my formal way is y equals mx plus b, where m is your slope or your rate, and b is your y-intercept. So here is my slope or my rate. So if I start writing this equation, I would have y equals 10 over 34x. Did it say anywhere in this problem I had a y-intercept or a starting value? At 0 minutes, would I have completed any problems? No. So technically, 0 is your y-intercept. You could say plus 0, but in most textbooks, you will see it as this. So this is the equation we are about to use. So it says use our equation to predict these amounts and round it to your hundreds place. Pause your video and remember we're using the equation y equals 10 over 34x. Use your calculator. You're going to plug in your values. For example, I would have y equals 10 over 34 times my x value or input of 5. And if you do that in your calculator and you round it to the hundreds place, you would have 1.47. Try to complete your table, pause your video, and then check to see if you have the same answers. Check to see if you have the same answers as I do. If you do not, make sure you plugged it in your calculator correctly. 10 divided by 34 times your x values or your inputs. If not, you can ask your teacher. And after 5 minutes, Josephine was able to complete 1.47 problems, which means she was able to complete one problem, then get about halfway through the next problem. So that's just something to think about. Compare your prediction from part A to the number you found in the table above. So my prediction from part A for 25 minutes, the actual data we have is about 7 problems. My prediction, I said 6. So I was fairly close and accurate. You may have been, you may not have been. That's just testing your prediction or estimating skills. Now it says to use the formula and plug in x is negative 7. So here was our formula, y equals 10 over 34x. Y equals 10 over 34 times negative 7. In my calculator, I would get roughly negative 2.06. Does this make sense? Explain. Absolutely not. Because you can never have, first of all, you can't have a negative amount of time, and you cannot have a negative amount of problems completed. So once you get answers, make sure they make sense in that situation. And lastly, for this problem, we assume that Josephine worked at a constant rate. Do you think that is a reasonable assumption for this situation? I mean, you may say yes, provide justification. You may say no. And to be honest with you, I don't think it's reasonable, because it does not take the same amount of time to do every single problem in math class. Think about your homework. If I gave you 30 problems, does it take you the same amount of time to do every single problem? Probably not. So just as a little recap, I want you to remember this information about functions. This is the big picture right here. Remember, it's a rule that assigns each input or x value exactly one output. They can be described by tables, graphs, equations, verbal descriptions, and the same x value is never assigned to a different y value. Basically, you can never have a duplicate input or x value. So I hope that helped you. That's all you need to do right now, and then your teacher will tell you your next step. Thank you so much, and have a wonderful day.